Alright, welcome. We are proceeding to another aspect of sets, which is finding the positive square root of a number. Finding the positive square root of a number. Or better still, you can still write it as the square root of an irrational number. The square root of an irrational number. Alright, so let's see one or two things here. If we have square root of a plus square root of b, take note of this. Now, when we square that, square root of a plus square root of b all squared. Let's see how best we can solve this. Now the two affect square root of a, so we get square root of a all squared plus 2 multiply this first term, then multiply the second term. So 2 times square root of a times square root of b. Then plus, we take the second term all squared. So square root of b all squared. Now square root of a all squared, we get a plus, here we get 2 times square root of, that's ab. Okay, square root of a times square root of b is square root of ab plus, here we get b. Now a and b, let's use it as 1. So we get a plus b, then plus 2 times square root of ab. So this is what we have. If we have square root of a plus square root of b all squared, we'll be using this a lot in our studies. Let's see when we have square root of a minus square root of b. Now let's see square root of a minus square root of b all squared. Now same thing, we have square root of a all squared, then minus 2 multiplies the first and the second terms, square root of a times square root of b, then now plus square root of b all squared, because it will be negative square root of b all squared. And don't forget that the square will take away the negative away. Negative 1 all squared is positive 1. So that's why we didn't write it. So now here we have a minus 2 times square root of ab plus we have b. So we get our a plus b, then minus 2 times square root of ab, 2 times square root of ab. And also we'll be using this in our solution a lot, so pay close attention to that. So first and second expansion, square root of a plus square root of b, square root of a plus square root of b all squared. Don't forget, it is a plus b all squared plus 2 times square root of ab. Then we have square root of a minus square root of b, and also we'll get what? A plus b minus what? 2 times square root of ab. So this is what we'll be using in our questions or our solutions. So take note of that. Now let's start solving 5 examples. We are solving only 5 examples. So follow me as we dive through. Alright, so let's see our first example. Find the positive square root of 49 minus 12 square root of 5. Find the positive square root of 49 minus 12 square root of 5. So let's see how best we can solve it. It's very simple. The solution is very simple. So follow gradually as we solve. Now, we want to find a positive square root. So 49 minus 12 square root of 5. They say you should find for the positive square root. So square root of this. And don't forget to equate it to, because it has a minus in the expression, we say that then it should be equal to square root of a minus square root of b. So when you check the expression and we have positive, or the expression it contains plus, then you use square root of a plus square root of b. When you check the expression and it contains minus, then use square root of a minus square root of b. Now we say we should find the positive square root. So the positive square root. Don't forget square root brings what? Plus or minus. So if I ask you square root of 4, it is plus or minus what? 2. Okay, so when square root comes, it brings plus or minus. So it is plus or minus 2. But here we are interested in the positive square root of that. So the positive side is what we are dealing with. So let's see how it goes. Now the square root of 49 minus 12 square root of 5 equals square root of a minus square root of b. We want to take the square root of. So what do? We square both sides. So square both sides. Square both sides of the equation. So we square both sides of the equation. So we have the square root of 49 minus 12 square root of 5 equals, so that's all squared here. Then square root of a minus square root of b, all squared. Now the square takes away the square root. So we have 49 minus 12 square root of 5 equals, now when we expand this, or in our previous video, we say when you expand you get a plus b minus, that's 2 times square root of ab. So that's the expansion for this. So this is what we have. 49 minus 12 square root of 5 is equal to a plus b minus 2 square root of what? ab. Alright, we go. So by equality of sets, we've done equal sets, equality of sets. 49 will be equal to a plus b because it's not inside square root. So 49 is equal to a plus b. So this one will be equation 1. And here we have negative 12 square root of 5. Then here negative 2 square root of 5. Don't forget negative or cancel negative. So you can ignore that. So I have 12 square root of 5 equals 2 square root of ab. And this will be equation 2. Now we'll be solving equation 1 and 2 simultaneously. We'll be solving equation 1 and 2 simultaneously. Now let's say from here we can divide through by 2 and all that. So let's ignore this one as equation 2. Let's proceed further. We divide here by 2, here also by 2, so that we get 6 square root of 5 equals square root of ab. Alright, so this is what we have. We square both sides to take away the square root. So here we square both sides of the equation. So we have 6 square root of 5 all squared equals square root of ab all squared. Now 6 square root of 5 all squared, don't forget it's the same thing as 6 square root of 5 times 6 square root of 5. 6 will multiply 6, then square root of 5 will multiply square root of 5. 6 times 6 you have 36 times square root of 5 times square root of 5 is 5. 5, 6, 30. 5, 3, 15 plus 3 you get 18. So that's 180. So you can straightforward write 180 here. Or better still, this is the same thing as 6 squared times square root of 5 squared. And we get 36 times 5, which will give us 180. So take note of this. Alright, so 180 is equal to, here we have AB. So this will be our equation 2. Don't forget we have the equation 1 to be 49 equals a plus b, and this is our equation 1. So now I've simplified the equation 2 further to obtain 180 equals ab, which is equation 2, then 49 equals what? A plus b, and that is what? Equation 1. Now we can solve equation 1 and 2 simultaneously using the substitution method. So solving equations 1 and 2 simultaneously using the substitution method. So we want to solve that simultaneously using the substitution method. So now let's see. We can make any variable the subject in either equation 1 or 2. You choose your own. Okay. So let's say in equation 1, make a the subject of the relation. In equation 1, make a the subject. So making a the subject in equation 1, we get a is equal to, that's 49 minus b, and this will be equation 3. We have equation 3. Now we substitute equation 3 because we chose equation 1 and we made a the subject in equation 1. Now we are done with equation 1. So what you obtained from equation 1, we send it towards equation 2. So now we substitute equation 3 into equation 2. So let's see how best we can do that. Alright, so this is equation 2. That's 180 equals AB. We are substituting equation 3 into that. So which means that wherever we see A, we substitute 49 minus B. So 49 minus B times our B. So 180 equals, using the distributive property, 49 minus B, we get 49b minus b squared. Alright, now we can send these two terms to the left hand side so that we obtain positive b squared minus 49b plus 180. Then this is equal to 0. The highest power of the variable is b, and the highest power of that is 2. So which means we are in the soup of quadratic. So we solve it quadratically. So what we have, we get two numbers when you multiply, you get 180, but when you add or subtract the numbers, you get negative 49. All right, so we have 4 and 45, which we get b squared minus 4b minus 45b plus 180 equals 0. Now we put that in bracket. B squared minus 4b minus 45b plus 180 equals 0. Common factor, we have b, then b minus 4, then minus here, common factor 45, we get b minus 4 equals 0. B minus 4, b minus 4, they are the same. We factorize b minus 4 out, then we have b minus 45 equals 0. Now we just use the now property. B minus 4 equals 0, so we have b equals 4, then b is equal to 45. So this is what we have. So now, since we have the values of b, two values for b, 4 and 45, we substitute b equals 4 into equation 3. And don't forget, equation 3 is this. So we get a to be equal to 49 minus 4. We get a to be 45. Same thing, we substitute b equals, that's 45 into equation 3. Into equation 3 here, so that we have a is equal to 49 minus b. A is equal to 49 minus 45. A is equal to 4. So here we can say that, let's say a and b. If our a is 45, our b is 4. And here let's say a and b. If our a is 4, b is 45. Okay. Now, this says we should find the square root of 49 minus 12 square root of 5. And this was equated to square root of a minus square root of b. Now, there is a condition here where a is greater than b. So always take note of the condition. A is greater than b. So if a is greater than b, then we select a to be 45, then b to be 4, even only if a is greater than b. So it will be square root of 45 minus square root of 4. Let's proceed further. Alright, so we'll get square root of 49 minus 12 square root of 5 is equal to, now square root of 45, that's 9 times 5. Then minus square root of 4, we get what? 2. So here when you split square root of 9 times square root of 5 minus 2, you get 3 square root of 5 minus 2. And this is just equal to 49 minus 12 square root of 5. So this is what you have. So the positive square root of 49 minus the positive square root of 49 minus 12 square root of 5 is just equal to what? 3 square root of 5 minus 2. Or better still, we can write it as negative 2 plus 3 square root of 5. Negative 2 plus 3 square root of 5. So that's the end of the first example. Very, very, very simple. We'll see the second example too as well. Alright, so let's see, find the positive square root of 3 plus 2 square root of 2. So let me divide the board so that we can get more space to do that. So the same thing, this one is plus. It's plus. Alright, so let's see, find the positive square root of that. Now this is plus, so we will use square root of a plus square root of what? B. So we take the square root of that here because they say we should find the positive square root of this. Now we square both sides. So we have 3 plus 2 square root of 2 equals square root of a plus square root of b all squared. Don't forget, when you square both sides, the square root will go away. So we have all squared here. Now, when we expand this 3 plus 2 square root of 2, and this is equal to a plus b plus 2 times square root of ab. That's what we have when we expand this. Now, by equality of sets, we have a plus b to be equal to 3, equation 1. Then we'll get 2 square root of 2 is equal to 2 square root of ab. Now let's divide through by 2. Here by 2, here also by 2. You get square root of 2 equals square root of ab. We can square both sides so that we have 2 equals ab. Or better still, ab is equal to 2, and this will be equation 2. By using the substitution approach, we can make a the subject. So we solve equation 1 and 2 simultaneously. So making a the subject in equation 1. So in equation 1, make a the subject. Make a the subject. So making A the subject, you have A to be equal to 3 minus B. And this is equation 3. Now we substitute equation 3 into equation 2. So we substitute equation 3 into equation 2. And equation 2 we have AB equals, that's 2. And A is what? 3 minus B times B equals 2. Using the distributive property, 3B minus B squared equals 2. We send these 2 times to the right hand side, so that we have B squared minus 3B plus 2 equals what? 0. Two numbers when we multiply we get 2, but when we add or subtract we get negative 3. Where we get B squared minus B minus 2B plus B equals 0. We put that in brackets, 2 times in bracket. So this is what we have. Common factor, we have B out, B minus 1 minus B out, we get 2. Wait. Here's supposed to be 2. Here's supposed to be 2. So common factor here is 2 out, B minus 1 equals 0. So we factorize B minus 1 out. So B minus 1 out. Then we get B minus 2 equals 0. By the now property, B equals 1, B equals 2. Now we have to get the value for A. So we substitute B is equal to 1 into equation 3. So that we have A is equal to 3 minus 1. A is equal to 2. Again, we substitute B equals 2 into equation 3. So that we have A is equal to 3 minus 2. A is equal to 1. So here, again, if we have AB, our A is 2, then our B is 1. If we have AB, our A is 1, our B is 2. So this is what we have, AB 2, 1, AB 1, 2. Very, very simple, very, very simple. So now, in all, we can say that if we have the square root of 3 plus 2 square root of 2, and this is equal to square root of A plus square root of B. Don't forget the restriction says what? A must be greater than B. So our A, we'll choose our A to be 2, so square root of 2 plus our B, we choose it as 1, so square root of 1. And this will be just 1 plus square root of 2. So the positive square root of 3 plus 2 square root of 2 is just 1 plus square root of 2. Very, very, very simple. So if you don't understand the video, please play back the video for better understanding. Let's see our last example. Let's see our last example and let's go. Very, very simple. Let's see our last example. All right, so let's see this one. Find the positive square root of 28 minus 10 square root of 3. So let's see solution. 28 minus 10 square root of 3. So we find for the positive square root of 28 minus 10 square root of 3, and this is equal to square root of A minus square root of B. Don't forget the condition, A must be greater than B. So we square both sides. 28 minus 10 square root of 3 equals square root of A minus square root of B, all squared. When you square both sides, this is what we obtain. Now we still have 28 minus 10 square root of 3 is equal to, when we expand, we get A plus B minus 2 times square root of AB. By equality of sets, we have a plus b equals 28, equation 1. Then here, negative 10 square root of 3 is equal to negative 2 square root of ab. Negative cancels negative. So we have 10 square root of 3 equals 2 square root of ab. We divide both sides by 2. So we have 5 square root of 3 equals square root of ab. Now, we square both sides again. So 5 square root of 3 all squared equals square root of ab all squared. Okay, so we go. 5 with 3 all squared, that's 5 squared times with 3 squared, which is 25 times 3. 3, 5, 15, 3, 2, 6 plus 1, 7. So we have 75 equals AB. And this should be equation 2. Now, solving equation 1 and 2 simultaneously. So we will have solving equation 1 and 2 simultaneously using the substitution method. So in equation 1, we make A the subject. We make A the subject here. So we get A is equal to 28 minus B, and this will be equation 3. We substitute equation 3 into equation 2. And equation 2 is AB equals 75. So A is what? 28 minus B times B equals 75. We multiply by using the distributive property. So it will be 28 b minus b squared equals 75. We send these two terms to the right hand side. We have b squared minus 28b plus 75 equals 0. And this is b. Now we solve it quadratically. So that's a quadratic equation. Okay, so here we'll get b squared minus 3b minus 25b plus 75 equals 0. Okay, so we put that in bracket. B squared minus 3b minus 25b plus 75 equals 0. Common factor b out, b minus 3 minus 25 out, b minus 3 equals 0. We factorize b minus 3 out. So b minus 3 times b minus 25 equals 0. By using the now property, we have b minus 3 equals 0, which is b equals 3, then here b equals 25. B equals 25. Now we have two values for b. So we substitute b is equal to 3 into equation 3. So that we have a equals 28 minus 3 is equal to 25. We substitute again, b is equal to 25 into equation 3, so that we have a is equal to 28 minus 25. A is equal to 3. Now check something. AB, our A is 25, B is 3. Our AB, A is 3, B is 25. Now don't forget the condition, A must be greater than B. So if we have square root of 28 minus 10 square root of 3, If a is greater than b, then we take square root of, let's say, a minus square root of b. Okay, so square root of 25 minus square root of 3. And here we get 5 minus square root of 3. So square root of a minus square root of b, our a must be greater than b. Okay. Alright, so that's it. That's it. Very, very simple. Alright. Very, very simple. Mathematics is not a spectator of sport. So sit down, take your calculators, take your jotters, and sit down quietly. Follow what the teacher is doing on the board, and I believe you understand. If you don't understand, play back the video several times till when or till the time you get the understanding. I believe you will understand this subtopic, finding the positive square root of a number. Very, very simple. Just put in mind that you sail through this subtopic, and I believe God will crown you with a success. All right, so the next time we meet, we'll try the spherical equation or the radical equation. So see you in our next video. Bye bye.